Hi everybody. I continue the third lecture about COVID-19. Now we studied about how the virus enters the cell and how we can prevent the virus enter the cell. Okay? But I have to mention about prevention of the viral in the first step when it is in the GI tract. The best, one of the best way for the treatment of the virus, we rinse mouth and the nose with the salty water, and also we can use carbon activatus or active carbon, because it can absorb the viral in the GI tract. Okay, and it can make because it usually cause severe diarrhea, and it is very important. Now the genome, viral genome inside the cell. Okay. If you want use a transcription of the strand, we continue with the transcription of strand. Okay. We need the protein. Okay, we need a protein which called RdRP. In the first lecture second lecture I spoke about it. RNA-dependent RNA polymerase. Okay, and we have to produce this protein. We will see how in the next part. But it is very important when the transcription of the strand happen, and we copy the strand because it is a 5 to 3, okay, and we have to copy it, and it will be 3 to 5, okay. Now, as you see here, okay, the process produce negative strand from the positive strand, because it is a transcription of the strand, as you see. Now we produce this strand. How we can prevent this mechanism? How we can inhibit RNA-dependent RNA polymerase, okay, enzyme? We can use with the two type of drug. It's very simple, which is very important, and I saw in the many articles it has a high effect. It is a Remdesivir. It can prevent this process, okay, and Favipiravir. Okay, as you see here, Favipiravir and Remdesivir, they can block the effect of the RdRP, RNA-dependent RNA polymerase, and in this situation, transcription of the strand, because strand can be never happen. Okay. Okay. Now we don't have a genome. We don't have a transcription of the genome. As you know, from the pharmacological background, the Remdesivir is the RNA-dependent RNA polymerase inhibitor, and as I spoke in the last lecture, RNA-dependent RNA polymerase is an enzyme that catalyzes the replication of the RNA from an RNA template, and we have an RNA template from the COVID-19, and now we copy transcript from that, and it catalyzes the synthesis of the RNA strand complementary to give RNA template, because we needed this RNA template for the COVID-19 replication, synthesis, new COVID-19 synthesis. Remdesivir can give as an infusion into the vein, okay? Usually for the patient in the hospital we need monitorization, and mainly in the hospital can we use Remdesivir, and it's usually given once per day for 10 days. It is because in these steps, this process stop. Okay, the genome is inside the cell, but the process which helps for the formation of the COVID-19 is stopped in this step. It is one of the important process we have to care about this. And also the second drug is from this group is the Favipiravir, as you see here, Favipiravir, and it is also like Remdesivir. It is a block RNA-dependent RNA polymerase, but it is a prodrug, and it's very important because this drug is a prodrug from pharmacological background, and it is metabolized to the active form. Okay, the active form is the FR5T, or we can say Favipiravir ribofuranosyl 5,3-phosphate, which is available in which can be active and effect for the RdRP enzyme. This drug we can find as orally or intravenous formulation, and the effect mainly because it's a prodrug. I saw in some articles they use in some hospital these drugs, and it has a positive benefits of this medicine, and it's very important. Okay, now the next step, it is very important. Until here is the very nice. This first step is good, but this step goes. But there is another direction of these steps is very important. From this viral genome can produce two type of the protein. It's very important. It is a PP1A. It's very important, and PP1AB. These two type of the protein, as you remember in the second lecture, in the structure gene of aspirin in the ORF1 and ORF1b, there was a genome we call 3CL protease. Okay, this mechanism with this synthesis can produce, they can help for the production of this protein. Okay, also 3CL protease. Okay, it is in the ORF1. Okay, open reading frame 1A, and it is, as you know, it is help for the proteolysis, and also for this protein helps for the production of it helps for the proteolysis and help for the production of some enzyme like RdRP. It's very important because this one helps for the production of this protein. Now we want to prevent this step. Okay, if I want to prevent this step, I can use two type of the medicine which can prevent this enzyme. Okay, we can prevent this enzyme with the two different drugs. The first one, Lopinavir. We can, with the Lopinavir, we can block the effect of the 3CL protease enzyme, which produce from the ORF1 genome transcription and translation of that part. Okay, and this steps go to the proteolysis and formation of the protein, which helps for this enzyme. It is very important. And the second one, it is very important, is a Ritonavir, and this is a very important drug, Ritonavir. Okay, these two drugs also can be effect for this mechanism. But as you know, in the ORF1, there is a two type of the enzyme product can be synthesized. This is the first one, the 3CL protease, and the second one was papillon-like protease. It also this step Also, we can prevent this step also. With these two drugs, we can prevent these steps, and as you know, 3-like protease enzyme catalyze the cleavage of the peptide bonds between the glutamine at the position of the P1, and the small amino acid serine, alanine, or glycine at the position of the P1. In this case, what has happened? Lopinavir is the we know is Lopinavir is antiretroviral drugs, which can protease inhibitor class. We can use mainly for the HIV treatment. But Lopinavir and ritonavir, which we call the Kaletra, is the fixed dose combination medication for treatment and prevention of HIV. As you know, in the pharmacological background of the treatment of the HIV, we use this medicine, and in the USML lectures I also mentioned about that, because these drugs mainly can affect for the prolongation of the HIV treatment, and because the benefits is prevent it prevents the viral replication, and it helps for the increasing the life of the patient. Okay, and the protease 3CL, as you remember, is a potential inhibitors. It is a potential drug target for the coronavirus also, because it is essential role in the protein, the polyprotein that are transit from the viral RNA, because it is from the pharmacological background. This mechanism lies exactly the same mechanism which we can mention in the HIV, and it is very important for us. And also the other treatment which is important for this one, for the Papillion like protease, we can use it Disulfiram, because Disulfiram, as you remember, these drugs mainly we use for the treatment of the chronic alcoholism, because by the producing of acute sensitivity to ethanol, and when the patient drink ethanol, and it has a high vomiting, it make this sensation in the patient, because it can inhibit also papain-like protease. You know, as you remember, the genome of the papain-like protease is in the ORF1 A, and it is also has the two properties, because this it can has a proteolysis effect, and also it is an interferon antagonist, which is very bad, because it can prevent effect of immune system and the viral, and it is also dangerous for the patient. And for this step, these drugs can affect for this mechanism. Now, from these steps, when we have this two strand, then in the next step we can replication of the structural protein. This is important, it's very important. Okay, and also plus nuclear capsid. Both of them is can be with the help of the genome and the genome. Okay, and goes to the membrane. Okay, and the other step is just the from the structural protein go to the ribosome, Golgi apparatus, packaging, then go to the membrane. Okay, because this protein will go to the membrane. S, N, E, and the M, protein production of this one, and both of them, and the genome, because you see the genome, and because this genome and nuclear genome, will be M protein plus the RNA. Okay, and this protein plus the membrane, it goes to the membrane, and it goes to the membrane, as you see to the membrane, and it can cause the budding of the virus. It can help for the formation of the virus, budding of the virus with help of membrane, because the membrane comes to the membrane and this genome comes and causes the budding of this system. How we can prevent this budding? As I mentioned here, it is with the interferon beta, because if we use the interferon beta, we can prevent this mechanism. It is very important, because with this interferon beta, we can prevent this mechanism, and it is very important with us. And the other systems, because this now COVID also can cause inflammation process. We can use Tocilizumab, we have said Actemra, or we can use Sarilumab. These two drugs is immunosuppressive drugs against the interleukin 6, because as you remember, when the inflammation happens, also the system is here, the inflammation process interleukin 6 increase. Okay, it can cause inflammation. Okay, for the prevention of the interleukin 6, we can use these two drugs. We see Tocilizumab and Sarilumab. If these two drugs is very important, we can use these two drugs for the prevention of the effect of immunosuppressive, for the prevention of the effect of interleukin 6. And it is, but these two drugs we mainly, as I mentioned before, we use for the treatment of rheumatoid arthritis, because this drug is very important. It can prevent interleukin effect, because interleukin is very important, and it is can affect for this prevention. Okay, and now for the main, then I can mention here the drugs, Actemra, okay, which, as I said for you, it's the Tocilizumab, and the Kevzara. These two medicines is very important. You can find in the hospitals in the US and Europe, and these two drugs is very important. And the Sarilumab and the Tocilizumab, it is the two main drugs for the inhibition of the effect of the interleukin 6. But the other system problems which is important for us today, I will continue the next lecture about the process which can cause the activation of the complement system and the coagulation cascade. I hope in the last lecture we will mention how we can recognize the process and how we can choose the best treatment in the treatment of COVID-19. I hope it will be good, and see you in the next lecture.